Hello students, welcome to AriserTalent. I am your maths teacher Arpita Sharma. Students, we are studying chapter probability, and in our previous lectures we have dealt with the basic formula and basic definition of probability, and we have discussed one or two questions about that. Okay, so now here is next questions, which is we have done that question. Okay, this question, right? Find the probability of getting a number less than 5, that we have done 2, and yes, that was the question we were on. On tossing 3 coins at a time, find all possible outcomes. Second, events of occurrence of 3 heads, 2 heads, 1 head and 0 head, and third, probability of getting of 3 heads, 2 heads, 1 heads and no head at all. Before going through this question, students, I have to make you understand about this. This is the word, today's word we will learn. Sample space. Now, what is this sample space? Like if I talk about this question where I am tossing three coins, right? So, if I am tossing 3 coins, 2 and 3, right? So these 3 are coins basically, and I'm talking about that. So the basic so the possible outcomes, if simultaneously these coins are tossed, then the possible outcomes are what and what, like that can be head, right? We have discussed that that can be head, tail, that can be head, tail, head, and so many more. So how you will write that? These combination. These are not only 3 combinations. We have discussed there are 8 combinations when it comes to 3 coin to be tossed. So they are remaining outcome too, but we are talking how to write them. Okay. So we'll use this thing that we will have that bracket. Okay. Then we will simply write this head and head. This is the one outcome. Okay, then we will separate it with a comma, then with a small bracket, then head, tail. This is one method. Or else what you can do, you can just simply write it head, then comma, then that was head, tail, and then comma, then head, tail, head, and the bracket close. So according to your relevance, you can write it like this or this, and this is what called sample space, right? This is a method of writing the possible outcomes. This is about the coin. In case of cards, you can write like that. In case of dice, you can write like that. Okay, so this is the way to write. Noted? Right. Now, we have done the question, but now we'll learn how to write it in an exam, in our board exams. Okay. So what we were having this formula PA, that is A is an event, okay, and P is probability of occurring an event A, right? And we have discussed this formula M by N, where M was what? M was favorable outcome, right students? Favorable outcome. And this N was total outcome, total possible outcome. Now how will we denote it further? If I am talking about PA, because in many questions, like in that one also, we have not only asked about one outcome, that's PA. PA is one, then PA can be the next possible case you are asking, the question may be asked to you, like all possible outcome. This is the first point. So we will write PA for that. Okay, so we have calculated PA. Let us assume that we have solved this question and we have find out this possible outcome. So that's not PA, that is your total outcome. Okay, so total outcome you have completed. Now In the second one, event of occurrence of 3 heads. Now, event of occurrence of 3 head, let us assume is as a PA. Now, we have find out PA, but now we have to find out 2 heads. Probability of getting 2 heads. Now, there is a comma. Okay, so we will assume it as PB. Probability of occurring that event B. Now, this event is B. So, this is the denotion basically. That will be PC, that will be PD and so on, right? Okay. Now, surely M and N. M and N are what? Basically numbers. Okay. If I talk about this M, right, it is a or we write it as N. Okay. So, these are numbers. Numbers, this is total number. Total number will be always denoted as NS. NS. Now, N and the bracket. This is the favorable outcome. If I am talking about PA, that will be NA. Now, similarly, if I am talking about PB to be find out, that will be NB upon NS. This is the same thing MN, but if I asked too many outcomes, more than one outcome, then this M will change because N will be constantly the same, the total number of outcome, but for first condition M will be different and for the second condition M will be different. So, there may not be too many values for single constant. Okay, meaning of constant, basically idea of a constant is what? Having only one value. So, we will describe it as NA, that is number of favorable outcome of occurring event A. Similarly, here number of probable outcomes of event occurring B, right? So, note this. Okay, this is the method that we are going to use to solve our questions, right, students? So, now with the question, you are given 3 coins. Okay, so I can just write here given what is given to you, 3 coins are tossed. Now, if 3 coins are tossed, number of total outcome we have discovered 8. How? If I talk about one, now listen to this very carefully. I am talking about 3 simultaneously, right? So, if they are tossing simultaneously, there will be a multiplication. Now, understand this. There are 3 and there is a multiplication because the coin 1 is tossed. Now, what are the number of outcomes of tossing, of getting any outcome from that coin? There are 2. That may be head or a tail, right? So, there are 2 outcomes. Total number of outcomes 2. If I am talking about the second number coin, again 2 outcome and again 2 outcome. So, getting the combination of these 3 coins to be tossed, we will be getting what? Multiplication in between, and 2 multiplied by 2 multiplied by 2 is what? 8. So, we will be getting total number of 8 outcome. Now, what I have told you, total number of outcome is what? N, and we are going to denote is now as NS. So, total number of outcome, yes, that is equals to NS equals to N. Now, the very first thing we have asked about, we have to write all possible outcomes, right, students? All possible outcomes. Now, is something you need to use your brains. All possible outcomes. I'm tossing 3 coins. What and what can be the cases? This is so simple. So I'm going to describe that event, possible events. Now how will I write? Set of that. This is the one. It can be a head, the first one, and I'm assuming the 3 will be the head. Okay. Now there may be a possibility then any of them may be a tail. So we'll work on that too. Head and tail. Now this is the first coin, this is the second coin, and this is the third coin. Now what will I do? I'll just have this possibility of getting the tail on the second number coin. Right? Okay. Now again this can be on the first number coin too. So these are the 4 cases. 3H, 2H, and again 2H and 2H. Now I can have 2 tail or I can have 3 tail. So I have started with no tail, then 1 tail. Now I'll be having 2 tails in the coins getting tossed. So head, tail, tail. Now I can replace that one is that tail, head, tail. So H can be there also. Now head can be on the third place, and it can also be a probable case that there will be first tail, second tail, and the third head. So I'll write that also. Right, student? Now the remaining one probability is having all the 3 as tail. Right. So these are the outcomes, total outcomes. Okay. So you may note that. Number of total outcome 8. What are the all possible outcome? These all. So done with the first one. Now what is asked in the second thing? The second thing we have asked about 3 hats, 2 hats, 1 hat and 0 hat. So 3 hats, 2 hats, 1 hat, or should I write it like this? Numbers 1 hats, 0 hats. Okay, I have the all possible outcome. I have just to count them, right? So this is the case A, this is the case B, this is case C, and this is case D. So let occurring 3 hats be the event A. Now implies that PA is equals to what? Simply NA upon NS. Now student, tell me what is NS? We have already calculated NS, that is equals to 8 here. So just write down 8 here. Now NA possibility of occurring 3 had. Now 3 had here. Here no, 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 no and no. So here's only one with 3 hats. So we can have that. So NA should be equal to 1 only, right? So we'll write it 1 here. Similarly, if I'll go with the 2 had case and I'll assume that as PB. So what will it be? That is for 3 had. Now that is for 2 had. For 2 hats, I'm just directly writing the value of N. Now here it will be B. Number of favorable outcome for getting 2 hats. Now I'm getting 2 hats here, 2 hats here and here, right? Other than that, I'm having only 1 hat or no hat or 3 hat. So 1, 2 and 3. I'm having 3 hat 2 heads in 3 places. So there will be 1, 2, 3 outcome. So NB will be equals to 3. If NB equals to 3, that means PB equals to what? 3 and the total 8. So this is your answer. Here it was your answer. This is basically the complete thing is also your answer. Right. Now, similarly, what is the next? 1 head and 0 head. Similarly, for 1 head, now for 1 head, you'll be having here 1 head, 1 head and 1 head. So basically, this is 1, this is 1 and this is 1. So 3, okay. That means PC equals to what? NC upon NS. Now NC is equals to what? Calculated like 3 and NS is 8. So again 3 by 8 is your answer. Right or wrong? Now for 0 head. For 0 head. Now if you are having 0 head, that means you are having tell. There is only one possibility, that's the last one here. Okay. So for 0 head, PD will be equals to ND upon NS and that will be equals to 1 by 8 and this is your answer. These are all the answers of part 2, right? So note this so that we can move further. Okay, noted. So now I am rubbing this so that we can move to the part 3. So now you know how to solve part 3, right or wrong? Right? Okay. I am keeping this because that will be our source. Now this is the probability of getting 3 heads, 2 heads, 1 head and no head. Okay, so what we've just find out. Okay, so what we calculated is actually 0.3rd event of occurrence of that is asked only event of occurrence. Okay, we have solved it for the probability of getting 3 heads. So correct that as the third point. We have done the third one. Now if event of occurrence of 3 head, so that will be simply what we have done here, events of occurring. So P, let's suppose A for 3 heads, that will be equals to what? And A, that will be equals to what? Head and head. Only one event, so we can use small bracket for that. That's for point number 2. Okay, and if I am talking about, this is for 3 heads. If I am talking about 2 head, for 2 head, that will be what? Head, tell, and tell me what? Head, tell, head, and the third one was tell, head. We have discussed this. Now the next one, 4, this was 1, this is 2 and this is 3. For 1 head, that will be head, tell, head, tell, and last one is tell, head. These were the 3 for 1 head. Now For the 0, we were having, for 0 had, we were having only one event. What was that? Tell, tell, tell. Okay, so that will be tell, tell and tell. So this is your answer. Okay students, now note this 2, that is your second point. The previous point that we have covered is the third point. Okay, note this. Alright, so should we move to the next question? Okay, so the next question is, what is the probability that a leap year selected at random will contain 53 Sundays? Now this is a good question. Okay, so you just have to understand it, what's trying to say, and here you are. What is leap year, students? You know about the leap year. Okay, so basically we are having 365 days in a simple normal year, but we don't like simple things. So normal year is having 365 days, but the leap year, my dear students, that's having 366 days. How many days? Yes, 366 days. Okay, so now if leap year is having 366 days, how many weeks it will have? Because it's talking about something like week, right? It's saying that what is the probability that a leap year selected at random will contain 53 Sundays. Now, if we'll have the number of weeks, then we can easily say this will be the number of Sundays it will be having, and basically it's saying that it will be having 53 Sundays. Now we will calculate it and we'll find out that it's very simple. It is very normal to have 52 Sundays, Mondays, Tuesdays, Wednesdays, whatever days in your normal year. 52 is okay, but 53 is something that we have to calculate. Now, how will you calculate? Simply you are having 366 days. So weeks, number of weeks, you just have to divide 366 with what? Weeks, that is 7. 7 days forms a week. So that will be give you 5, here 35, will give you 1, then 6, 2 and then 14, we will be remaining with 2. No further division, students, simply that is weeks and this is remaining days. So basically if you are having a calendar year of 366 days, then that means you are having 52 weeks plus 2 days. Now be careful about that because this is the soul of your question. These 2 days left. There's nothing to deal with these 52 weeks, but the remaining 2 days, because they are 52 weeks. That means you are having 52 Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Now the question arises with these 2 days. I am having these 2 days, day 1 and day 2. Now what can be the possibility? That either that can be Sunday or that can be Sunday, because after Sunday a Sunday cannot come. Okay, and if it is Monday, then here it will be Sunday, right? So this is only the 2 cases. Okay, so this is technically we are understanding the question what it is. Now we'll be doing the question. So you understood how will we finding the weeks and remaining days in this question? Right? Okay. Okay. Solution. So it's giving me the leap year days. Okay, so start with, in a leap year, number of days. Number of days, I've taught you very well, 366 days. So, number of weeks and remaining days equal to 52 weeks plus 2 days. Now you won't be questioning me about how that 52 week came, because we have discussed that. How? We just divided that 366 by 7, we got 52. Okay, and remainder 2 was the number of days. Okay, so these 2 days. This implies that we have 52 Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday in the year. So for having 53 Sunday, 2 days left. Now day 1, day 2. Possible cases I am talking about. What can be the possible cases, students? I'm just thinking if this could be the Monday. If this is the Monday, or it could be the Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday. This is what I need it to be. Sunday. Okay, let's see. I'm getting what I want or not. If it's Monday, if the day 1 is Monday, after Monday that will be becoming Tuesday. That's for sure. So Tuesday, then Wednesday, then Thursday, then Friday, then Saturday, and then Sunday, and then Monday. So students, I am getting these 2 situations of Sunday. This is the one where I am getting the day 1 as Sunday and day 2 as Monday. And the second one is when I am getting the day 1 as Saturday and day 2 as Sunday. Now in either cases, my wish is fulfilled. In this 1, 2, 3, 4, 5, 6, 7. In these 7 cases, I am getting 2 cases in which I am getting my Sundays as one of the day, the rest of 2 days. So 53 Sundays. Okay. So if I'll just cut it short in language, then I'll be writing it as total possible outcomes for remaining 2 days equal to what? 1, 2, 3, 4, 5, 6, 7. You can write in like that in set form also. Okay, your space format. Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, and Sunday, Monday. I can write write that for you also. Like we can write it like Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Okay, this is 1, 2, 3, 4, 5, 6 and yes, Sunday and Monday. Right students, and out of these I am having this Sunday here and this Sunday here. One time at day 2 and one time at day 1. So, total number or outcome are what? 7. 7. Now come here. You're having this what you say? NS. Implies that NS equals to total outcome is equals to 7. Favorable outcome or favorable events is equals to what? If you look carefully there, that is your Saturday, Sunday and Sunday, Monday. Only 2. So, this implies that N of A, I am assuming that to be an event A. So, N of A is equals to 2. Now you know what are you looking for? Probability of happening that event A is equals to N of A upon N of S. That will be going to 2 by 8 and that will be going to 1 by 4. So, students, 1 by 4 is what? Your answer. Okay, got it? So, note this question completely. Okay, so noted? So enough of questions for today, but what we are going to do, I am having a question for you guys to practice it. Okay, and I'll give you some clue for that, and what you have to do, you have to solve that. Okay. Yes. 3 unbiased coins are tossed together. Find the probability of getting all tails 2 heads, maximum 1 tails, at least 2 heads. Now you have to do it on your own, and these 2 particular situations you have dealt with the very first question I have taught you today. Okay, this is where there you asked about all heads, that is 3 head. All head, that means 3 head, because 3 coins are to be tossed. Then 2 heads you have done, so 2 tails you can also done. Maximum 1 tail, that means you can have 0 tail and you can include that one in your favorable outcome, 0 or 1 tail in that case. At least 2 heads, that means the outcomes having 2 head will be included. Now this is at least 2, that means 3 head will be included in that also. So just do some brain exercise, do this question, and we will meet in the next lecture. Okay, take care, bye bye.